In this video, we are reviewing how to multiply expressions involving exponents. So remember that in these, the base is the number on the bottom over here, and then the exponent is the little number up here. So 5 to the third is saying that we're going to do 5 times 5 times 5. So the exponent is telling you how many times to multiply that number. So same thing for 5 to the fourth. That is going to be 5 times 5 times 5 times 5. And again, there's 4 of them because of the 4 right here. So when we're simplifying these, we know that we're just multiplying these all together. So we're just going to count up how many 5s we have. So we have 1, 2, 3, 4, 5, 6, 7. So my answer is 5 to the 7th. And that represents that there are 7 5s. Okay, so same thing for B. I'm going to expand this. So x squared is x times x. There's just a y by itself. For the second set, x cubed, or x to the third, is x times x times x. Again, there's 3 of them because of the exponent. And then we just have one y at the end. And then again, I'm just going to count up how much I have of everything. So there's 5 x's, so that's x to the fifth. And there's 2 y's, so that's y to the second. So all you're doing is just expanding these and then counting how many of each letter or number you have. All right, so for C, we're doing the same thing. So x cubed, or x to the third, is x times x times x. The only thing that's different here is this negative exponent. So anytime you have a negative exponent, remember that just means repeated, instead of multiplication, it's repeated division. So we learned that like 5 to the negative 2 is 1 over 5 squared. So anytime you have that negative exponent, you're taking this and moving it to the bottom, and you're throwing away the negative. Because again, it's like saying we're dividing by 5 over and over again instead of multiplying. So same thing here. I'm going to take x to the negative 2, and I'm going to throw it on the bottom of this problem. So I have x times x, because there's 2 of them. Again, when you throw it to the bottom, the negative on the exponent goes away. And then I still have y to the fourth, which is times y times y times y times y. So the only thing that changes on this one is that if it has a negative exponent, it's going to move to the bottom of the fraction. And then now that I have that, I can just start canceling stuff on the top and the bottom, because I know that x divided by x equals 1. And so I'm allowed to use my giant 1 and say, okay, well, that equals 1 as well, so I can just cancel that out. Okay, so these two cancel because that's 1. X divided by x is 1 again. And now I just count what I have left over. So I have 1x, and then I have 4y, so that's y to the fourth. So again, we're just expanding, and then if it's negative, you're going to put it on the bottom of the fraction. And so what's the shortcut? Let's say you don't want to have to expand all these every time. So I noticed here that if I had done 3 plus 4, I would have gotten 7. And then so my shortcut is that I can just add the exponents, but only when they're in this format. So again, like if I had 5 to the third times 5 to the fourth, I could have just said, okay, well, what's 3 plus 4? And that's 7. And if you forget that, you're welcome to expand it. So that also worked for B because I have x squared, so x to the second and x to the third. Okay, well, 2 plus 3 gave me 5 right here, so that worked out. And then on B, when something doesn't have an exponent, there's an invisible 1 right here. Okay, so 1 plus 1 would give me 2, so that checks out. And you could have done the same thing for C, even with that negative. So if I add 3 plus negative 2, that's going to give me 1. And so I can see right here that I just got x to the first power. And then with the y, there was nothing, so just y to the fourth. So you don't have to use this shortcut, but if you don't feel like expanding everything, then that's always the way to go.